Okay guys, so welcome again to our second lecture wherein we will discuss our module 3 uh, which covers the topic matrix multiplication. So previously ang dinefine pa lang natin ay addition, subtraction of matrices, tapos ngayon proceed tayo sa multiplication. But before we proceed to multiplication, we will define uh, a certain operation na gagamitin natin all throughout the discussion, which is the dot product or the inner product. Okay, so suppose we have n vectors in Rn. So pag sinabi nating vector, usually this pertains to a column matrix. So isang column lang siya na n by 1. Okay, so we have n rows and 1 column. So suppose that A and B are vectors and vectors. Pag kinuha natin that product nila, magiging ganito yung itsura niya. So this one, okay, so magiging ganyan yung itsura niya. A1 times the, parang pag multiply lang natin yung corresponding elements nila, okay, and then ipag-add natin yung mga product na yun, and then yun yung tinatawag natin na dot product. Okay, so take note that before we perform dot product, kailangan parehong column vectors, and then syempre kailangan pareho yung size natin. Okay? Okay, so we have here an example. So find the dot product of 1, negative 2, 3, 4. So we have u times v. So note that pag dot product, kailangan ini-indicate nyo yung dot ano. So kasi we might perform usual matrix operation. So kung u tapos v lang yung sinulat nyo, it will not be defined kasi nga ito ay 4 by 1, ito rin ay 4 by 1. So matrix multiplication would not be possible. Makikita nyo yan later on. Okay, so punta muna tayo sa dot product. So u dot v is just equal to 1 times 2, which is 2, plus 2 times negative 3 is negative 6, and then 3 times negative 2 again is negative 6, and then 4 times 1 is 4. So we have a negative 6. Okay, so ang dot product ng u at sa v ay negative 6. Okay, how about the next one? So next example, let A and B be 3 by 1 vectors. So we have A to be equal to x, 2, 3, and then B equal to 4, 1, 2. If the dot product of A and B is equal to negative 4, we need to find x. So how do we do that? Computein muna natin si dot product. A dot B is equal to 4x. So pag multiplyin lang natin yung corresponding elements, 2 times 1 is 2, and then 2 times 3 is 6, which is equal to, sabi dito, equal daw siya kay negative 4. Okay, so simplifying, we get, pagsamahin na natin, magiging 4x plus 8, okay, which is equal to negative 4. So solving this equation gives us x equal to negative 3. Okay, so we have here our next example. So one application of the dot product is that we can use it to compute the general weighted average. Okay, so pwede nyo gamitin ito para makompute yung weighted average nyo. So okay, so suppose that we have 4 weights. Okay, so and then 4 grades din. Okay, so yung 78 na grade, ang weight niya ay 10% ng GWA mo. Yung 84.3 and then 0.3. So what we want to do here is hanapin natin yung weighted grade mo. Okay, so weighted grade. Yeah. So forming the dot product, we get 78 times 0.1 is sige, isulat na lang muna natin. 78 times 0.1 plus 0.3 times 84 plus 0.3 times 62, and then 0.3 times 85, which leads us to 77.1. Okay, so that means that our weighted average is 77.1. Okay. Okay, now we want to use this dot product to define what matrix operation or what matrix multiplication is. Okay, so suppose that we have A and B. So, syempre kung magmumultiply tayo ng matrix, kailangan meron tayong dalawang matrix. Okay? So, suppose that A is equal to A sub ij is an M by P matrix. So, we have M rows and then P columns. Okay? And then B is a P by N matrix. So, we have B to be a matrix with P rows and N columns. Okay? And then the product of A and B can be written as the following. So tatawagin muna natin siyang C to be C sub or equal to the matrix C sub ij, okay, generated by C sub ij where, yeah, okay. So we have the following. So C sub ij is just equal to A sub i1, B sub, ito yung, bale itong C sub ij na to ay yung ating ith row sa jth column. Okay, so yung element natin na nasa ith row and then nasa jth column, equal lang siya sa ai1 times b1j plus ai2 plus b2j plus etc. etc. Okay, and then we'll simplify lang natin siya using this summation notation. Okay, so take note na ang nagbabago lang dito sa paghahanap ng C sub i element ay yung I dito sa A. Ano ba yung I natin? Yung row na gusto natin hanapin. So, basically, ang dinadot product natin ay yung row ni A at saka yung column ni B. Okay? So, row ni A saka column ni B, yun yung pinagmumultiply natin para makuha yung element na gusto natin dun sa matrix na C sub ij. Okay, mas madali siya makita I think dito sa picture. So, what I mean is this. So, para makuha so suppose that this one is A, or ito nga si A, and then ito si B. Kung kukunin natin yung mga entry nila, kailangan mo lang i-dot product ito. For example, hanapin natin yung C sub ij. So, yun na nga, kukunin natin yung J column ni B, at saka si I row ni A. And then, i-dot product natin. Pero note that ito ay nakahiga. So, kailangan natin siyang itayo. We will perform what we call the transpose. So, na-discuss naman na yung last meeting. So, we have the transpose of the row, ith row of the matrix A, dot product, the jth column of B. So, we will get the C sub ij element. Okay, basically, para makuha mo yung dot product, ay yung matrix product natin, you have to do a series of dot product. So, para makuha natin si C11, kailangan natin i-multiply yung, or i-dot product, yung first column ni B, at saka yung transpose nung first row ni A. Okay? Ganun natin makuha si C11. Okay? Okay, so ano naman, kung ba gusto natin kunin si C sub mn, kunin natin yung nth column at saka yung mth row transpose and then i-dot product natin. Okay, so medyo meticulous yung process ng paghahanap ng matrix product. Okay, yeah, okay, so we have this illustration. So take note that hindi tayo pwedeng mag-multiply ng matrices pag iba yung column. Kailangan yung column ni A ay pareho ng row ni B, or else hindi mag-exist yung ating product, ano. So take note nyo lagi yan, and then yung resulting matrix natin ay M by N. Okay? Yeah. So kailangan pareho yung column ni A sa si row ni B before we proceed to multiplication. Okay? So we have here an example. So we have A equal to 1, 2, negative 1, 3, 1, 4, and then negative 2, 5, 4, negative 3, and then 2, 1. So we first multiply is, so yung kukunin natin yung dot product muna, no? So para makuha itong unang element, dinot product natin ito, tapos yung transpose nito. So we get 1 times negative 2, 2 times 4, tapos negative 1 times 2. Okay? Ito siya. Okay? And then kung kukunin naman natin yung second dito, kukunin natin to, ang ginawa lang natin ay ito, idadot product natin sa transpose nito. Okay? And then similarly, to get this one, this element, kailangan natin i-dot product ito, tapos ito. Okay? And then next, to get this one, dot product natin ito. Tapos ito. Okay? Okay. So, proceeding with simplifying, we get the following matrix. So, sorry, nakalimutan ko i-check. Pero this A here is a 2 by 3 matrix, and then this one is a 3 by 2. So, pareho. So, pwede tayong mag-proceed sa multiplication, and then yung magiging size niya ay 2 by 2. Okay? Next, we proceed with example 3. So, compute the 3, 2, and 3 of AB. First, i-check natin kung pwede nga ba siyang i-multiply. So, A here is a 3 by 3 and B here is a 3 by 2. So, pwede tayong mag-multiply, and then ang makukuha nating size ay 3 by 2. Okay? So, what we're going to do here is, since ang hinahanap natin ay si 3, 2, and 3 ni AB, kailangan nating i-multiply yung third row ni A transpose sa second column ni B. Okay? So, third row ni A transpose times the second, times product, dot product niya kay second row or second column ni B. Ito yung magiging itsura niya. So, yun na nga. So, third row ni A transpose times second column ni B, or times dot product pala. And then, pag kinumpute nyo ito, makukuha nyo ay negative 5. Okay? So, here we have an example of a problem-solving solution, or meron tayong problem na maglilid sa isang linear system. So, let's check first kung pwede nating ipag-multiply. Okay? So, we have here a 2 by 3 and then a 3 by 1. So, yung magiging resultant natin ay 2 by 1. Okay? So, pwede naman tayo mag-multiply. And then, we have here the fact that the product is equal to 12 and 6. So, I assume na hahanapin natin yung values ni x at ni y. Performing the matrix operation, we get this one. So, meron na tayong 2 plus 4x plus 3y is equal to 12. And then, 4 minus 4 plus y is equal to 6. Note that two matrices are equal if and only if parehong-pareho yung entries nila. So, in this case, kailangan itong nasa taas equal kay 12, and then itong nasa baba equal kay 6. So, magkakaroon tayo ng system of linear equation. So, para isolve to, madali lang naman. Since sa baba, magsi-0 lang to, and then we get y equal to 6. Plugging in 6 into the previous, or into the first equation, we will get x equal to negative 2. Okay? Okay. So, we have here the following cases. Suppose that A is a M by P matrix, and then B is a P by N matrix. Okay? So, note that AB will exist. But, if AB exists, this does not mean that BA may exist. Okay? Yeah, this will take place when N is not equal to M. Okay? So, yeah. So, hindi porket merong AB, makuha na natin si BA. Hindi to siya tulad nung normal na multiplication natin, ano? Okay, so if BA is defined, then malamang yung if AB and BA are both defined, malamang BA will be a square matrix. So, ang size niya ay P by P. Okay, while AB will be an M by M. Okay, so pareho silang square matrix. Okay? So, in the case where M is not equal to P, then AB and BA are of different sizes. Okay? Okay. If AB and BA are both the same size, they may be equal. So take note that may, may yung ginamit niyang term kasi hindi naman siya necessarily equal. Okay, so BA is not always equal to AB. Okay? Yeah, this is what I'm saying. Okay, so let's proceed with the following example. So A is a 2 by 3 matrix and then B is a 3 by 4 matrix. Then AB is a 2 by 4 matrix while BA is undefined. Okay? Bakit BA is undefined? Okay, kasi we have here the column of B is not equal to the row of A. Okay? Kaya siya undefined. Okay? And then next, let A be a 2 by 3 matrix and B be a 3 by 2 matrix. Then we will have here a square matrix. So AB is 2 by 2 while BA is 3 by 3. Both exist but they are of different sizes. Okay? And then the next one we have the following. So both matrices are 2 by 2 but this does not necessarily mean na equal sila. If we perform A, so this one is B pala, so hindi ko na isulat. So if we perform AB, so AB is equal to this matrix while BA is equal to this matrix. Note that two matrices are equal if and only if pare-pareho yung bawat entry nila. Since magkaiba sila ng mga entries, we conclude that AB is not equal to BA. Okay? Okay, here we have another example. Okay, so we have here a 3 by 2 and then a 2 by 3 matrix. So meaning matrix multiplication is possible. Okay, so in this case, we only want to find the second column of AB. Okay, we do that by multiplying the matrix A with the second column of B. Hindi na natin kailangang i-perform yung buong matrix multiplication. No? Para makuha yung second column ni AB, kailangan lang natin i-multiply si A sa isang column, sa second column ni B. So in this case, we get the following. So we have A times the second column of B, which is equal to 3, 2. Possible ba to? Yes, because this one is a 3 by 2 and this one is a 2 by 1. So we will have a 3 by 1 matrix, which is 7, 17, and 7. Okay? Okay, so we have here a remark. If U and V are n vectors, so n by 1, then it is easy to show by matrix multiplication that U, yung dot product ni U at V ay equal lang sa U transpose times V. So, yeah. So, understood na pag walang product here, we do matrix multiplication. And pag sinulat natin yung dot product, so don't misuse that. So, dito, si dot, sa matrix operation, si dot, we use it to indicate a dot product. Okay? Okay. Okay, so, now we have the next topic. So, pwede pala nating isulat daw yung matrix vector product in terms of its columns. Okay? So, what does this mean? Kung baka meron tayong matrix and then i-multiply natin siya sa isang column vector, pwede natin siyang isulat in terms of the columns alone. So, what does this mean? So, suppose we have A equal to the following matrix. So, we have an M by N matrix. Okay? And then C is a C by N or an N by 1. And this one is an N by N. So, matrix multiplication is possible. So, performing matrix operations, we get this one. Okay, so ang resulting vector natin dito ay since m by n and then n by 1, this will result into a m by 1 matrix. So magkakaroon rin tayo ng isang column vector. Okay, so how do we do this? So forming AC, we get the following. This one is A and C. So i-distribute natin. So kukunin natin yung transpose ng mga rows. Okay, and then idadot product natin siya kay C and we get the following. So, row 1 of A transpose times C, row 2 of A transpose, dot product C. And then we get the following matrix. So, meron tayong column. Okay. Now, note that, anong naging itsura nito? So, parang ito yung ating first, diba? First column ni A. Pero nakamultiply lang kay C. Plus, second column ni A, nakamultiply kay C2. hanggang kay nth column ni A nakamultiply kay C sub n. So, pwede pala nating isulat to as the following. Okay? So, pwede natin siyang isulat as C1 times the first column of A plus C2 times the second column of A, etc. hanggang kay C sub n times the nth column of A. And then we get the following. So, we write it as a ganito, as a linear combination of the columns, wherein yung coefficients natin ay yung numbers na kay C or dun sa ating vector. Okay? Okay, so here we have 2 by 3 matrix and then a 3 by 1. So yung resulting vector, yung resulting product natin ay magiging 2 by 1. Okay? So the product of AC can be written as the linear combination of the following columns. So hindi na natin kailangan i-dot product na. So pwede lang natin gawing 2 times the first column. So we have this one. And then negative 3 times the second column. And then 4 times the third column to get the following values. And then simplifying, we get negative 5, negative 6. So it is an easier way of solving vector times a matrix. Okay? So next we have the following statement. So suppose that A is an M by P and B is a P by N. So possible natin i-multiply. Then kung kukunin lang natin yung jth column ng product, okay, we can get it as the following. So the kth column of, or the jth column of AB is just equal to the matrix A times the jth column of B, which will lead us to the following values. Okay? So, ito yung mga entries ng column ni B. Okay? So, we have B2J or B1J. So, B2J, ito yung laman ng jth column ni B. Okay? And then, i-multiply lang natin siya sa mga columns ni A. So, nagkaroon ulit tayo ng following value. Okay, so B sub 1J times the first column of A, B sub 2J times the second column of A, etc. Okay, so what this value gives us is the jth column of AB. Okay, so we have the following example. So if A and B are matrices defined by 10, so pwede by 10, okay. So ito, asan na si 10? Ito si 10, okay. So we have A and B to be equal to this one times this one, and we will get this the following value. So suppose na gusto lang nating hanapin si 4, 6, 17. So yung first column natin. So we just multiply A by the first column of B. So we have, saan na si A? Okay, so we have A times the first column of B. So we have negative 2, negative 2, okay, negative 2 times this one. Okay, so to get this one, plus 3 times this one. Okay, so ito yun. Okay, so they are both equal, ano? So if you solve this one, we will get 4, 16, 17. And then ganun din sa iba. So hindi mo na kailangan computein tong buong matrix para mahanap yung column na gusto mo. So suppose we have the this one, we need to find the second column of the product. We just get matrix A times the second column of B, which is the following. Okay, ito yung makukuha natin. Okay, and then the third column is as follows. Again, we multiply A by the third column of B to get the following value. Okay, hindi na natin kailangan computein itong buong matrix kung ang hahanapin lang naman natin ay isang column. Okay? Okay. Now we proceed to linear system. Since linear algebra to, we want to use matrices in order to solve linear systems. So here we present another way of writing linear systems. Okay? So suppose we have the following linear system. So we have ilan yung equation natin dito? We have m equations and then n variables. Okay? Therefore, we must have m times n na coefficients. Okay? So, we define the following matrix. So, we have A here to be, so, kukolektahin lang natin lahat ng coefficient natin. Yung mga A11, A12 hanggang kay A sub mn. So this one is an m by n matrix. Okay, and then we have here the vector. So we have here the x1, x2. So ito yung ating mga variables. Okay, I guess we can call this the variable vector or the variable matrix. And then B here is the following matrix. Okay, actually we have a name for A. This one is called the coefficient matrix. Okay, now we can write the linear system as follows. Okay, so we have A times X to be equal to the following product, which is correct naman, no? So isinulat lang natin siya as a matrix form. Okay, now we define the following matrix. So sabi na nga natin to kanina, A here is the coefficient matrix, and here we have a new type of matrix. So if we write yung linear equation natin as the following, so we have here the coefficients, and then yung mga equivalent value niya or yung nasa right side ng equation natin, which is B1, B2 hanggang kay Bm, we call this the augmented matrix, or we can write it as the following. So A, which is our coefficient matrix, and then we have here a vertical line B. So ito yung ating augmented matrix. This is another way of writing our linear system. So understood na dito na hindi na natin kailangan isulat yung mga variables na x, no? So parang given na agad. Okay? Yeah. So we have here the coefficient and the augmented matrices play key roles in our method for solving linear system. So later on, gagamitin niya natin itong augmented matrix na to. We will form row reduced echelon form, or we will have matrix manipulations in order to come up with solutions of linear systems that are complicated or very meticulous when it comes to algebraic manipulation. So instead of solving it by elimination, substitution, we will solve it by using matrix operations. Okay, so recall from our first module that, or our first lecture, that if we have the b sub i's to be equal to 0, then we call that system a homogeneous system, and we can write it as follows. So A times X is equal to 0. Note again that A here is the coefficient matrix, and then si X dito ay yung ating variable vector. Okay, so huwag niyong kakalimutan na whenever letter is written in bold, usually isa siyang vector or a column vector. Okay, and then a capital letter A is just a matrix. Okay, which is equal to 0. So dito, since naka-bold din si 0, we know that 0 here is the 0 vector. Okay, so we have the following. Consider the following linear system. Gusto natin siyang isulat as an augmented matrix. So what we do here is collect the coefficients. So we have -2, 0, 1. May 0 tayo dito kasi wala naman tayong y sa first equation. Tama? So we usually write it in order. Kumbaga x, y, z, ganun. And then kung ABC naman yung ginamit natin, edi ABC yung order. Okay? So we have here -2, 2, 3. Okay, -2, 2, 3. Since walang coefficient si y, we will write 0, 3, and 2. And then ang coefficient ni z ay 1, -4, saka 2. And then our variable matrix here is x, y, z. And then b here is 5, 7, and 3. Okay? Therefore, to write the augmented matrix, we get the following. So ito lang si A, and then we have a vertical line, and then si B. Okay. Again, let's find, given the augmented series, okay, augmented naman, hanapin natin linear equation. So, it's customary to use the variables x, y, z. Because pag ABC yung ginamit, parang ang dinedenote kasi nun ay yung entries ng matrix natin, di ba? Tandaan nyo yung mga, parang sa mga previous lessons natin, ang matrices usually ay A, B, at saka C. So, we tend to avoid that. Okay, pero variables lang naman yan, depende rin sa pagde-define nyo. Okay, so the following augmented matrix is equal to the following linear system. Okay, so now we have AX to be equal to the following. So ito yung equation 5 natin kanina, no? Pakibalikan nilang. And then, using equations 2 and 3, so take note that 2 and 3 is yung ginawa natin before, wherein minultiply natin yung matrix sa mga columns niya. Okay, parang in-express natin yung product ng matrix sa yung vector as a linear combinations of the 2 using the coefficients that is in the vector. Okay, so what I mean is this. So here ax here is the matrix, and then x here is our vector. So we can write it as the following linear combination. So we have x1 times the first column, x2 times the second column, plus etc. hanggang kay x sub n times the nth column. Okay, so we will have the following. So x1 times the first column of A, x2 times the second column, plus etc. etc. Okay, ginamit lang natin yung na-discuss natin earlier. Okay, thus ax, okay, so ito yung sinasabi ko kanina, is a linear combinations of the columns of A with coefficients that are the entries of x. Okay, it follows that the matrix form of a linear system can be expressed. So we have here another way of expressing a linear system. So we have x1 times the first column of A, etc., which is just equal to B. So B here is a vector as well. Okay, consider the following system: ax equal to B, where the coefficient matrix is given by this A. So A here is a 4 by 3 matrix, and x here is a 3 by 1. So multiplication is possible. So consistent naman yung system natin. Okay? We write ax equal to b as a linear combination. So yung ginawa natin kanina. So x1 times the first column of A, x2 times the second column, and then x3 times the third column, which is just equal to the matrix B. Okay? It's just another way of writing our linear system. Okay? So if ax equal to b is consistent if and only if B can be expressed as a linear combination of the columns of the matrix of A. Okay, if we cannot express B as a linear combination of the columns of A, then our matrix is inconsistent. Okay, or wala tayong solution. Okay? Or the system rather is inconsistent. Walang solution. Okay, so I think that's it. Thank you for listening. So watch the video, and thank you for watching the video, and then comment your name down in the comment box or comment section, okay, for your attendance. Okay, I will be uploading the module after maybe 1 or 2 hours. Okay, so thank you.